So hey guys, welcome to the channel Learning Competitive Programming with Code Chef. If you want to learn competitive programming and ace in data structures and algorithm, this is the prime location for you. Every week there are several videos regarding the editorial videos of Code Chef contests which are held every month and the videos which will enhance your skills in competitive programming. So if you are new to the channel, then please subscribe the channel and turn on the bell notification. So myself Chirayu Jain, I'm a Code Chef educator and this is the part 3 of binary search of concept videos. Okay guys, so now let us understand the binary search iterative approach, right? So in the previous part we have learned about the binary search, what binary search is, why do we require binary search, as well as we acquire the knowledge of binary search using recursion, right? So now in this video we'll look at the iterative solution. So the whole process is similar, the way of thinking is similar. So if you have not watched the previous videos, please do watch it, right? The whole thinking is similar, but instead of recursion we'll try to do iteration, right? So let's see how we can do this, right? The whole process is same. We'll find the mid, we'll make the two things, that is the left and the right, and then we'll just manipulate these things, right? So if you are very new to the binary search, let's again try and run the whole process, right? So what we used to do in binary search is, firstly we have a search space, we need to find an element, right? So let us say that let us take some number that is the similar with 13 we need to find, right? Likewise in the previous video we also took 13, so let's take here also, let us take 13, the number which we need to find, right? So in this particular array which is of size 10, we need to locate 13. So firstly we'll divide the array into two parts. How we will divide this is first by finding out the mid. So how many methods are there to find mid? That is two methods. One is low plus high by 2 and the other one is low plus high minus low by 2, right? So in the previous part we came to the conclusion that this is the more efficient method because it will stop the overflow of the variables, right? So it will stop the integer overflow and it will get the appropriate mid if the values of low and high are pretty much great numbers there are, okay? So if the values of low and high are very high, basically they are of range 10 to the power 10, right? So now this is the more efficient way, so we'll find the mid using this. So first of all, what does low denotes is the leftmost index, so this is low and this one is high, right? So these are the two variables. So firstly we'll mark the indexing is 0 1 2, the indexing of array 0 based indexing, 6 7 8 and 9. So this is the indexing. So first step is find the mid. So what is the value of mid? That is the low is 0 plus high is 9 minus 0 by 2, correct? So the answer comes out to be 4.5 and we'll take the integer value, that is 4, correct? So the value of the mid is 4. So here we are now at this point we are. So this is the mid. Now what we will do, firstly we'll just try to match the values, that if 11 matches with 13 or not, right? So we'll try to match it. It doesn't match, so what we need to do, we need to make two search spaces. So one is this search space and the second one is this search space. So these are the two search spaces which we are getting, correct? Now we need to decide that at which search space we need to just iterate and get the value from. So as we know that since it is a sorted array, right, so all the values before 11 must be less than 11 and all the values which are above 11, which are on the right side of the 11, must be greater than 11, right? So if we are locating 13, that means it must be on the right space. Why? Because 13 is a number which is greater than 11 and all the numbers greater than 11 are on the right side. So this is the space which we need to search on, right? So automatically this space is of no use, and that's how we are decreasing half of the members of the array, right? So now we'll proceed to this particular search space. So while going to this search space, what we need to do, we need to update. Now since low was pointing to this variable, now low will point to this particular number, right? So now this is the low, so the new low is this and the high is same, right? Again we need to find the mid. So what is the formula, right? So the formula is that low, which is now at what index, that is 5, plus high is 9 minus 5 by 2, correct? So again the value comes out to be at index 7. So this is the mid, right? So same process we did in recursive also, right? While understanding the process of recursive approach, we followed the same thing. But in the iteration approach, we'll just try to use a loop and then finish off the things, right? Rather than just using the two recursive calls of the binary function, not necessarily two. If a particular if condition encounters, then we follow one iteration, one recursive call, and if the second condition hits, then we'll follow the second one, right? So instead of following that recursive call, we'll just try to sum up the whole process into a single loop. Let's see in the coding section that how we are doing this, right? So again, we'll find out the mid. This comes out to be 19. 19 does not match with 13, correct? Now we look at the section. So which section to look on? Since 13 is smaller than 19, so obviously it must lie in this particular section, right? Because all the numbers less than 19 are coming before, right? So in both of the search space, we'll just try to locate the number, but in this search space it is of no use. Why? Because all the numbers are greater than 19 and the number we are looking is 13. So in this search space, again, we'll just follow the same thing. Now low will be the same position and high will update, which is pointing to the number 17, that is index 6. So we have two indices. Now again, applying the same formula, 5 plus 6 minus 5 by 2, which comes out to be 5. And since the mid is 5, then we got our answer, that is 13. So this is the same thing that we did in recursive approach, right? All the logic is same. But in recursive approach, what we're trying to do, that we are giving our solution, like let's say that we got the point that the number is in this search space, right? So what we are doing is we are again calling that function. We are saying that, okay, I know that the answer is in this search space, so try and get me the answer. So what we are doing is we are again making a recursive call of the function binary search and just passing the lows and highs, the updated one, the updated low and the updated high, we are passing on to that particular function. So this is the recursive way. But in the iterative way, what we need to do, we just need to loop out the things, right? So while updating low and high, we need not to make a recursive call in that particular loop only. We just try to sort it out. So how we can do this? How we can just think and make the iterative approach while using our knowledge that we got from the recursive approach, right? So let's just try to understand this particular iterative approach, which you will be using mostly, right? So recursive approach is the approach which you know for the understanding, but iterative approach is the mostly used approach in binary search. So that let's try to understand how we can develop the code for this particular approach. Okay, so now let us understand how we can form the iterative approach. So we have known that the idea is same that we are using in the recursive approach and the iterative approach, just we need to do some modification. In recursive we are trying recursion, in iterative we need to loop out the things, right? So the whole thing is similar. We are using a main function, the array is of size 10, and these are the elements which are in sorted order. Now we are calling a binary search function in which we are passing the array, the starting index, that is the left or low, we can say, the rightmost index, that is the high, and the value which we need to search. So I have took a random value that is 77. So let's take a value which is already present in the array. So let us take a value that is 23. Okay, so it is a function binary search and there are the inputs that we are getting, right? So now first of all, in recursive approach, what we are trying to do, first of all, we are trying to get the mid, right? We are trying to get the mid. So what is the mid? That is int mid equals to L plus R minus L by 2, right? So this is the mid that we got. Now if you remember, at the last point of the recursive approach, we used to take a condition, that is if L is less than equal to R, right? And inside that condition there are recursive calls for a particular search space, right? So here if we are looping out the things, so in the loop we need to make a condition that is L must be less than equal to R. So how we can make that condition? And for that condition only the things must process, right? So we should use a while loop over here, while, right? So while L is less than equal to R, still this condition is true, do the following things, right? So this is what is the meaning of while loop. While this condition holds true, do the following things. So that's exactly we want in the binary search also, right? So while L is less than equal to R, we must do the following things. That is step number 1, calculate the mid. Now the same condition, if array of mid equals X, then what we'll do, we'll return mid. That's the important condition, that if mid the value at mid matches with the value which we are searching, then return the index. Otherwise, in recursive approach, what we need to do, we need to first check the condition that if array of mid is less than X, then we need to search the right search space, right? That means X is greater than array of mid, right? So we need to go to the right search space. So here we are not having this particular recursive call over that function, right? Simply we are using a while loop of L and R, right? So we are using a while loop in which we have two things, that is L and R. That means these two variables must be updating, right? So as we took the example of this particular iterative approach, so we are updating L, right? So if we are searching in the right space, we are updating L, right? Since we need to search the right search space because array of mid is less than X, that means we need to update L. So what will be the L? What will be the value of L? Since the value is greater than the value which is stored at array at mid, now the L must be equal to mid plus 1, because right search space starts from mid plus 1. So what will be the L? L will be equal to mid plus 1. Otherwise, if we need to search the left search space, then what will be L? L must be the initial value only, right? What is the value of L? Whatever it be, right? So L must be that value only the right one updates. So if we need to search a left search space, if we need to search the element in the left search space, then we will update mid by mid minus 1, because this is the search space which we are concentrating on. So the value of R will be mid minus 1, right? So we will not update L, we'll update R, right? Because we are searching the left search space, right? So this is how we will think of forming the approach iteratively. And what is the important condition? This is the while loop, right? This is the while loop. Okay, so here we ended that, right? So it must be ending over here, correct? This is the whole while loop, right? And if we do not get any element throughout this while loop, that means the element is not present in the array, so we'll return out minus 1. This is the condition where we are not getting the element, right? So let us run this particular code. I hope you are getting the solution, because this, what is the difference between the recursive and the iterative approaches, that we are here just finding out the element using a simple loop, right? Okay, so now let's just run this particular code. Let's see that if it is able to get this element 23 on the index that is 8. Yes, it is able to get that. Let's see the element which is 2, the first element. So if it is able to locate the index is 0 for that. Yeah, the index is 0. And let's search a random number that is 98, which is not there in the array. So it must return minus 1. Right? Yeah, it is returning minus 1. So this is how we develop the iterative approach of the binary search, right?